Okay, let's continue the potentiometer with this example. So we have a circuit, which is a potentiometer circuit, that we have 1.5 volt cell and a resistor of 990 ohm here in series with that, and then we have a wire PQ. This is a meter wire, is a resistance wire PQ connected across the two ends here. And then below here we have another battery E and a galvanometer with the sliding contact. So this is the part that is connected to the potentiometer. We are going to look at this one in a while. Okay, let's focus on the series connection of the circuit here. So it's mentioned that the meter wire PQ has a resistance of 10 ohm. So let's name R as 10 ohm. Okay, and the total length of PQ is 1 meter because it's a meter wire, and we assume it's a uniform cross section. Okay, so 0.7 meter is where the contact is, and of course the rest is 0.3 meter. Okay, just to lay out the information. So now let's look at the first question. Calculate the PD across wire PQ. PD across wire PQ. So don't be intimidated by this. You just have to view PQ as a resistor that is in series with the 990 ohm and also the 1.5 volt cell. Okay, so this is 990 ohm and this is the R 10 ohm. Okay, so it looks much simpler when I draw it this way, 990 ohm and 10 ohm series. So very clearly that this is going to use the potential divider rule if you are looking for the PD across the wire PQ. Okay, so this is the VPQ that the question is asking for. Right, applying potential divider rule, which is the ratio of its resistance 10 ohm divided by the total resistance 10 plus 990 ohm and multiply by 1.5 volt. Alright, if you forgot about this, you refer back to the previous notes. Okay, so once you got this, it's supposed to be 10 divided by 1000 times 1.5. So answer will be 0.015 volt. Okay, it only takes 0.015 volt out of the 1.5 volt of the driver cell, which means that the rest is taken by 990 ohm resistor. Okay, and this makes sense. Second question, using your answer in 1, calculate the PD across P and a point 0.7 from P. Okay, across P and a point 0.7 meter from P, so which means that is these 2 points here. Okay, so still we do not need to look at the circuit part of the circuit below here. We just need to now view that resistor as two resistors. Okay, from what we have drawn just now, we just break it into two more resistors. Okay, across it is 0.015. Across this is 0.015 volt. Okay, so this one has a length of 0.7, this one has a length of 0.3. So we have two resistors here expressed in terms of their length. So remember, if this is a wire of a uniform cross section and it's in series, the current is the same, the cross sectional area is the same, the resistivity is the same, and therefore we have potential difference directly proportional to the length. So if you want to find the 0.7 meter PD, so what we need to do is we just need to use the 0.7 is what we're looking for, and maybe we can use the 1 meter. Okay, V of the 1 meter, since we already got that. So this is 0.7 meter. Here we used 1 meter instead of the 0.3 because we don't have the PD for the 0.3, though we can find that. Not very difficult, just minus it from the 0.015. Okay, so this is the 0.015. Sub in this, then you should be able to get the V of 0.7. Okay, so which is this part here, V of 0.7, which is what the question is asking for. Okay, then you should get 0.0105. 0.0105. Okay, so next part of the question, let me erase this one first. Okay, next part of the question, if the galvanometer shows 0 at a point of 0.7 from P, what is the EMF E? So galvanometer, as I mentioned earlier in this topic, is a sensitive ammeter. Okay, it sends current. So it has the needle in the middle when there's no current. If current flow this way, then it will bend to here. If current flow this way, then it will bend to here, and then it's very sensitive. So if the galvanometer needle is not moving, it shows you that there's no current flowing. In this case here, it says that the galvanometer shows 0 at a point 0.7 from P, so which is this one here. So it's like you are doing an experiment to find, to detect where the galvanometer stop moving. So as you move to the left and to the right and along the wire PQ, it will just keep changing in this value. Okay, current will just flow when you don't find the right point. So the right point here is at 0.7, and it shows you 0 current when you arrive or achieve that moment or that point. So what it means is that current is 0. So let's label it first. What it means is that the PD across the whole thing here, okay, this connected wire until the terminal of this battery, this whole thing here, they are the same value. Okay, they have the same value, and this part of it, let me use a different color. This part of it has the same potential. Okay, so let's say here is a 1.5 volt, and here is V, slightly less than the, let's say V1, slightly less than 1.5. So which means that all along this wire here, there's no potential drop, it's all V1. So when you have no potential drop, then the current will not flow. Okay, on the other side also has no potential drop, so current will not flow. Okay, that's the idea. Current will not flow. Okay, that means the potential along this wire on the right hand side and the left hand side, they are the same value. Okay, so they ask what is the EMF. So when that happens, means that your PD across the 0.7 meter just now, the potential difference, which is 0.0105, 0.0105, that's the PD here, between here and here. Okay, so that must be also the same value as the EMF of this E. Okay, probably it's a bit hard to imagine. Now you picture a different situation. Instead of this, we have a voltmeter. Okay, we have a voltmeter. Instead of this, we have a voltmeter. Let me change the color. We have a voltmeter that we measure the PD across these 2 points. So voltmeter is a high resistance device. High resistance device means that current won't flow. When current doesn't flow, when you place this voltmeter across, it measures the PD across the 0.105 volt. So same thing here, when you have the battery and you tap it at a point where it shows you zero current, that's like E is like a voltmeter. So which means that it is also reading the same value as your 0.7 meter part of the wire. So which means that the answer is 0.0105 volt as the EMF of that. Okay, so if you don't understand this, you try to review this a few times, and then you should get an idea. Okay.